Hello. Let us try to understand the significance of a diode which is used usually across a relay coil. This is the relay coil, and a diode is typically used in this fashion across the relay coil. We have deliberately put a switch here, though it never exists in actual circuit, to understand what happens if the diode is not there. And this relay is being driven by a transistor, and then we are deliberately giving some on and off continuously to see the function of the real function of this diode. Actually, what happens that while the relay is on, the current flows through the transistor, and when the relay is off, the current doesn't flow. But while the relay is on, and the current will not flow in this direction, because the diode conducts in one direction. People call it forward biased, reverse biased. Forget about it, those are all engineering terms. But then actually the current will flow only in this direction. Current will not flow in this direction. As simple as that. So what happens when the relay is switched on and the power supply is positive here, the relay switches on through this. The current flows from here to the coil and then to the transistor, to the ground, to the negative. But when we switch it off, now supposing the transistor switches off and then the relay in the process is switched off, what happens? The current will try to flow here, but since there is no path because the transistor is open, so it will try to force a voltage across the transistor, which will eventually may result in failure of the transistor. To avoid that, what we do is we provide a path by this path. Now supposing the switch is closed, we provide a path by this, and then that energy which is stored inside the coil is dissipated in the diode. It functions only when this is switching off. It doesn't have any function while it is switching on. We will see this and while we operate certain condition. Now let's see this. Now while we operate this, what we notice. Now what we have done, we have connected a CRO. The channel B is connected to the input, that means what kind of input we are giving, and channel A is connected across the transistor. We would like to see what happens when on and off situation takes place. At this point in the process, the transistor also switches on and off, and in fact when this is high, this is low. When this is low, this is high. There is an inverter application which comes into picture here, as we have seen in other videos. Now we will see what happens that while we bring the circuit into operation. Now see, initially let me put the diode in connected position. Now the diode is in fact this is the exact situation in which the circuit is used. Now while we operate this, now what we find, this relay is operating on and off because I am giving an input of on and off. See, I am giving an input of on and off. Now let's expand this so that you can see it better. So the yellow one, as we have seen, the yellow one is the across the transistor, and this blue one is the input voltage. Now when the input voltage is, now we will try to switch off remove the diode. Now once we remove the diode, you see what happens. At the time of, you see all the pulses. We bring it to this, see all the pulses. Now what happens while, or again go back to this so that you can see it better. Right. Now what you see, this is the input, that while the transistor is switching off, this voltage, there is an extra voltage to the, now if you take the scale is your 5 volts, and in a circuit of 12 volts, so this has got 5 into 4, about 20 volts, which is superimposed over the voltage across the transistor. Now if we switch on this diode, you see what happens. Now this entire voltage is gone. It's pure this thing. How? Where the current in the off time will start flowing through this diode, and that is how the voltage spike which is appearing, which was otherwise appearing across the transistor, because the yellow is connected across the transistor, as you will see, the yellow one is connected across the transistor, and the transistor will eventually fail if it is not able to withstand that kind of voltage. So this is what is the function of that diode, and people call it free wheel diode, people call it number circuit, people call it dV by dt. So many factors they use. They are, of course, as far as the engineering concept is concerned. But as a layman's language, it's as simple. The energy stored in this is dissipated during the off time through this diode. During the on time, this doesn't have any function. This is what is the real function of this particular diode. Next, we will go to little complicated version of this number circuit.